2 on chemical energetics. So for this lesson 2, our focus will be on calculating bond energies for a given chemical reaction. So at the end of this lesson, you'll be able to perform simple calculations on bond enthalpy for a given chemical reaction. So let's do a quick recap of what we learned previously on endothermic and exothermic reaction. Now, for endothermic and exothermic reaction, looking at exothermic reaction, we learned that heat energy is being given out when a reaction is exothermic, from the word exo, external, and thermic simply means thermal. Okay, and how do you recognize an exothermic reaction? So the enthalpy for the reaction, which simply means heat change or change in heat energy, is usually negative. So you see delta H equals to minus 30 kilojoule per mole. When you see this sign attached to a chemical reaction, it simply means the reaction is what? Is an exothermic reaction. And for endothermic reaction, how do we recognize an endothermic reaction? Delta H is positive. So if you see a sign delta H plus 30 kilojoule per mole attached to a reaction, it simply means that that reaction is an endothermic reaction. And an endothermic reaction involves absorbing of heat energy, taking in of heat energy, from the word endo to internalize, and thermic meaning what? Thermal. Okay, so for today, basically want to focus on bond breaking and bond making. Bond breaking and bond making. Generally, for chemical reaction, when chemical reaction takes place, it is possible that you have both bond formation and bond what? Making. For example, if hydrogen reacts with water, and of course you need to recall your formation of covalent bonds here, it's very important. Hydrogen react with oxygen to form water. That's balancing the equation to form water. Of course, you know that your hydrogen, you have a bond between hydrogen and hydrogen. For oxygen, you have this bond. So in water molecule, your water molecule is represented like this. So I basically have two of this water molecule. That means I have two of these, okay, formed here to balance it. Then I have two of these, formed. Yeah, that's pretty good. Okay, so now looking at this, for this oxygen to combine with this hydrogen, hydrogen itself must be broken such that you have 4 hydrogen atoms pieces, and the bond between oxygen and oxygen has to be broken so that you have 2 oxygen what? Oxygen molecule pieces. So they come on the product side and recombine to form what? Water. So you have the breaking down of your compound or element into respective atoms. Then to form a new compound, the atoms have to what? Recombine, okay, to form a new compound. So here it's obvious that bonds are being broken. Okay, bonds are being broken here, while here bonds are being formed. So it's simple when we say that a chemical reaction is accompanied by bond formation and by what? By bond making. Okay, so let's proceed and capitalize on that idea. So why are there energy, in this case temperature change, seen in chemical reaction? Okay, energy changes occur in chemical reaction because chemical reaction involves bond breaking and what? Bond formation. So let's bring that home. Look at this compound. This compound is called methane. This compound is called methane. Okay, so how many bonds can you see here? How many bonds can you see? Okay, we have a bond here, 1, 2, 3, and what? And 4. So we have 4 bonds here. Basically, we have 4 carbon to what? To hydrogen bonds. 4 carbon to hydrogen bond. 4 carbons to hydrogen bonds. Okay, there. Now, looking at that, if this compound is to react, these bonds definitely will be broken down, such that if the bonds are broken down, then we are going to be having, if bonds are broken down, we are going to be having one carbon atoms, okay, and 4 hydrogen what atoms. Now to get these, we must have broken down 4 carbon to hydrogen bonds. So when 4 carbon to hydrogen bonds are broken, it's going to give us 4 hydrogen atoms and what 1 carbon atoms. Okay, so now when breaking a chemical bond, you want to break a ruler, for example, or a stick, you need to exert energy. Okay, this is okay, this is a stick that I want to break. Okay, now to be able to break this stick into the 2 pieces, I need to exert what? I need to exert energy. That simply means energy is put in. So for chemical reaction to be endothermic, energy is put in. So if energy is put in, then it must be what? Endothermic. So when a chemical bond, okay, is broken, energy is given in. But on the other hand, when a chemical bond is formed, energy is what is given out. Now I need you to put your hands together. Okay, don't clap it, just put it together. Did you hear any sound? Now put your hands apart and clap your hands. You can hear sound. Okay, the sound is produced because your hands came together. That sound is a form of energy. Now put your hands together again, rub it against one another. Keep rubbing, keep rubbing, keep rubbing. After a while, what do you feel? You definitely feel it feels slightly hotter. That is heat energy being given out. So whenever bonds are made, 2 things come together in chemistry, energy is what? Energy is given out. So you need to retain that idea. You need to retain that idea. If these come together with these, they are coming together, releases what? Releases energy. Bah! If the 2 of them come together, energy will be released. You know, but in this case, the release of energy is in form of heat energy, and so we say the reaction is what? The reaction is exothermic. So let's put the idea together quickly. So when breaking a chemical bond, energy is put in, and so such reaction is said to be what? Endothermic. When making a chemical bond, energy is given out, such reaction is said to be what? Exothermic. So basically, breaking of bond is endothermic, while making a bond is what? Exothermic. Okay, so you may want to form a mnemonics here. This is Brendo. Brendo is breaking of bond is endothermic. Olo, breaking of bond is what? Endothermic. Breaking of bond is endothermic. So making a bond will be what? Exothermic. So you may want to form that is Maxo. Brendo Maxo. Brendo Maxo. Brendo Maxo. Breaking of bond endothermic. Making a bond is what? Exothermic. Okay, I think that will help you. Okay, so now just to recap, you can see here, if energy is absorbed, the bonds are what? Broken. Here, when the 2 of them come together, energy is what? Released, then a bond is what? A bond is formed. So quickly, just reflect and use viewpoint to summarize what you have learned so far. Okay, now let's see how we can use this idea to calculate what we call the bond the bond enthalpies. Now for every chemical bond that is made or broken, a value is attached to these bonds, and this value attached to this bond is known as the bond energy. The bond energy for a particular bond is simply the amount of energy that needs to be supplied in order to break the bond, or the amount of energy that will be released when such a bond is made. I repeat, bond energy for a particular bond is the amount of energy required for breaking a particular bond, or the amount of energy that will be released when such bonds are broken. So basically, you do not need to memorize this data. It will always be supplied for you. So what you just do is to use the data to solve problems. Okay, so let's look at an example. Methane plus oxygen forms carbon dioxide and water. In order to be able to solve this problem very well, you will need to go and revise the formation of covalent bond. Okay, methane as a compound has four bonds. Has four bonds. You can see methane. Your oxygen here has double bond, but we have two of these, two oxygen here. So I'm drawing two of these. Okay, two of that needs to be drawn. Two of these, you can see. So but on the other hand here, I have carbon dioxide, one formed, and of course I have water. The covalent bonds diagram for water is this. Okay, so I have two of these formed here. So now on this side, so you should know basically what will happen here will be breaking of bonds. Bond has to be broken here, but on the product side, bonds are what? Bonds are formed. Okay, bonds are formed. You may need to pause the video and listen to it carefully again. So if you look at that, that's basically okay what happened. So we need to ask questions. How many bonds were broken here? How many bonds were broken? You need to break four carbon to what? Hydrogen bond. 1, 2, 3, 4. Break that. 4 is broken. Now each of carbon to hydrogen has what value? 435 kilojoule per mole. So that's why we have 4 times 435. Now for oxygen, we need to break this bond and also break this bond. So we have two of these, okay, oxygen to oxygen bond being broken, and each oxygen to oxygen is 497. So that's the value multiplied by 2. Okay, here bonds being formed. This is the bond being formed. We have oxygen to carbon bonds being formed on this, on one hand here, and on the other hand we have oxygen to carbon bond being formed. So what is the value for that? That is 803. How many of that we have? 1 and 2. So you have 2 times 803 value. The same thing for water. Okay, for water, how many bonds are being formed? We have oxygen hydrogen bonds being formed, oxygen hydrogen bond being formed, and each of them has 464 kilojoule per mole in terms of value. So I'm breaking this one, I break the second one 2, I break the third one 3, and the fourth one 4. So I have 4 of these being formed. So multiply it together. So the next thing to do is to calculate everything. All these, the value of these will be this, the value of these will be this, the value of this will be this, the value of this will be this. So next thing, we need to add all of this together and add all of these together. So what we got here, we got this, okay, 2734, and this 3462. Now the question is, what would this reaction be overall? For bond broken, we said that energy needs to be what? Given before a bond can be what? Broken. So how do we show energy given in? It's positive. So it is 2734. Okay, if energy is released, because when bonds are formed, energy is released. So we represent this by what? 3 4 minus 3 4 6 2. So basically, if you add the two together, you need to find what will be the net, energy. If I borrowed this and I formed this, so altogether on the average, net, I'll be having a net value of what? Minus 728 kilojoule. So ultimately, this reaction is said to be an exothermic what? Reaction, because it is given out. How do we know it is given out? Because the net value is what? Is negative. So you can see it's very simple to calculate, okay? And that can be shown on the energy level diagram. Can be shown on the what? The energy level diagram, where we'll start with methane and what? And oxygen. Starting with methane and oxygen, and as the reaction proceed, you can see as the reaction proceed, this amount of energy is what is taken in, okay, to arrive at this level, okay. But okay, to arrive at that level, but the moment that takes place, to form carbon dioxide and water, this amount of energy is what is given out. So we need to find the net difference. The net difference will now be the difference between, okay, this level that we have, okay, and this level, okay. That net difference gives us what? This value. You can see the difference, okay. We started from here, okay, we went all the way and we ended what? Here. So the net difference, when you take it back to your graph, okay, you find a deficit of 728. That shows that this reaction is what? Is an exothermic what? Exothermic reaction, okay. So your classwork, quickly do this classwork, pause the video, do your calculation, okay, then self-assess yourself. Just pause and self-assess yourself and put your score in your notes, okay. You need to own your learning, so display a sense of integrity here, okay. So your second class activity will be this: draw the energy level diagram for the reaction below. So for the reaction between hydrogen and chlorine, draw the energy level diagram. So when you are done, pause the video, do the activity, and assess yourself using this sample response, okay. So I'm going to see you in lesson 3. But to recap what you have learned so far, you can do this true or false exercise, and also assess yourself based on this sample response, okay. Mark yourself over 5, and this will be your assignment. I will see you again in lesson 3.